The logo is made up of three sectors, two of them being congruent, and we're asked to find the angle AOB, so this one here. Well, on a straight line, the angles add up to 180, which in radians, because that's what we're working in terms of here, it's going to be pi. So therefore, we'll have pi minus theta. That will be these two angles here. But because they're the same, because we're told they're congruent, we can then just divide by 2. Can we leave our answer like that, or maybe write it's a half pi minus theta. Show that the area is given by a half r squared 3 theta plus pi. Well, I have three sector areas to find, although these ones are the same. So I'm going to call them, I don't know, let's call them A1 and I'll call them A1 and A2, and then this one can be A3. So A1, don't forget the area of a sector formula when working in radians. It's a half r squared theta. This comes from drawing a sector with an angle of theta. The fraction of the circle that we have is theta over 2 pi, and I'm timesing that by the area of the whole circle, pi r squared. The pi's cancel, leaving us this, a half r squared theta. So remember, learn that formula, and I'd say learn how to derive it. So A1 is going to be a half r squared, because that is the radius here. But then my theta, because sorry, this theta is actually different from the one in the question. It's the theta in the sector. So my theta is going to be pi minus theta over 2. And that means that A1 plus A2, I'm just going to double it. It's going to be a half r squared pi minus theta. That just leaves us A3, which is going to be a half r squared, but now r is actually 2r, so half 2r squared theta, which is a half times 4r squared theta, or 2r squared theta. Okay, we're basically there. So the area of the logo is going to be a half r squared pi minus theta from A1 and A2 plus 2r squared theta. We just need to show that we can simplify it to this. I think the easiest thing to do is just expand it out and then refactorize it. So a half r squared pi minus a half r squared theta. And I'm going to write this as a half times 4r squared theta. Get it back like that, because now I can factorize the half and the r squared out actually. So a half r squared pi minus theta plus 4 theta. And that will finally give me a half r squared 3 theta plus pi. Okay, if you're feeling confident, you can actually factorize just the half r squared out straight away and kind of deal with it, but I think this is quite a safe route. Hey, finally, find the perimeter of the logo, giving our answers in simplest form in terms of r, theta, and pi. Okay, let's do this step by step. So here I've got 2r, and then I'm going to add on, oh yeah, I should have said this. So the arc length of a sector is actually, so we call it L sometimes, is equal to, or sometimes it's called S actually, S or L equals r theta. That comes from, again, theta over 2 pi for the fraction of my circle times by the entire circumference. The 2 pi's cancel, leaving us r theta. So remember, this here was a half pi minus theta. So it's going to be a half pi minus theta times r. But then there's two of them, so I'm going to times it by 2. Then I'm going to add r, because that's r, but that's also r, so actually I can add 2r. And then finally, it's just this bit, which is going to be r theta, but r, remember, is 2r here actually, so it's 2r times theta. Okay, let's just simplify this. So there's 2.5 are going to cancel, so I'm left with 2r plus pi r minus theta r plus 2r plus 2r theta. Then we can simplify this, so I'm going to have 4r, and the 2r theta minus theta r is just going to become r theta or theta r. And I've got my pi r as well. I think let's factorize it to finish. 4 plus theta plus pi times r. That is a nice simplified answer for the perimeter of the logo.